All right, so this is what the final copy of today is going to look like. All right, so what you're going to do is take that piece of paper that I gave you that has all the examples on it for today, and you're going to glue it towards the top of your page on the back of page 1. So here was page 1 that we did yesterday, right? Here's page 1 that we did yesterday. You're going to glue it onto the back of page 1. Okay, kind of towards the top, because we're going to have this little flappy here that we add on tomorrow. So leave room for that little flappy for tomorrow. Okay? Go ahead and pause for me. All right, so like I said, you need 2 highlighters. Okay? Yep, about 2 different colors. And today we're talking about expressions, which is like what we did yesterday, right? Remember that flap we did yesterday talks about expressions? What are expressions made up out of?
Numbers, letters.
Numbers,
letters, and variables.
numbers, letters, variables. So what types of numbers?
Whole numbers.
Constant.
A constant. Okay, so a constant is a number by itself, so that's one type of number. What's another type of number?
Just
Look back if you want to.
this
Yeah.
next one. A
Coefficient. Okay, good. So Austin, what's a coefficient?
A coefficient is number multiplied by a variable.
Good. So can you tell me an example of what a coefficient might look like?
Like if it was 3a, the 3 would be the coefficient.
Good. Excellent. Okay. So we're looking at
2 is the coefficient.
2 is the coefficient here. You're right about that. Good job. All right, so what we're looking at is the expressions here. This expression has 2 what?
Variables.
2 variables, right? We got an x and a y. But we're also given, in the directions, we're given values. It says evaluate each expression for x equals 8, y equals 5, and z equals 4. So I think you guys probably did this in 8th grade. Okay, this should look pretty familiar.
Well, we had a number instead of both of them being x and y. We had one of them a number and one would be a letter.
Oh, okay. Okay. So what we're going to do is we're going to say, all right, this is an x. So I'm going to highlight that right there. And then I can tell that from the directions, every time I see an x, I should take out the x and replace it with an 8. Right? So underneath right here, I'm going to put an 8. And then I have a plus symbol. And then I have another variable. I have a y. And I can tell from my directions that every time I have a y, I should replace it with a 5. So I highlighted it in a different color to show that differentiation. Okay, so I have 8 plus 5 right there, which is 13, right? Okay, now I also have z equals 4.
You didn't need the Z.
We didn't need the z, right? So basically it's just extra information.
It's just I'm trying to trick you.
Just trying to trick you. Okay, that's good. As long as you did it a different color. So you don't confuse yourself. All right, so what is my answer?
13.
13 is the answer, right? We'll box it so I know it's an answer.
Is this what algebra is? Is you have 2 letters and it'll tell you the numbers? Or?
That's pre-algebra. We're kind of starting with pre-algebra. And then next week I'm going to give you some equations where it doesn't tell you what the letter is. You have to figure out what the letter is.
Holy
We'll do that next
I
week.
see what you mean, like there's a 7 plus something and then the answer.
Right. And you have to figure out.
Minus the.
Yeah, y'all have done that.
What's the
Oh,
equation?
that's what you're talking about. Like algebra would be like x plus y equals 72 and you got how x and y.
We do that, but not yet. We build up to that. Okay, so let's look at example 2. All right, example 2 says, evaluate each expression for m equals 3, n equals 2, and p equals 9. So here, we already talked about that this 2 is acting as a coefficient. When you have a coefficient in front of a letter, what does that mean? What operation is that?
Multiplication.
Multiplying, right? So this is saying do 2 times the value of p. What is the value of p? 9. That's given to us, right? I know that the value of p is 9. It tells me that right there. So here's how I want you to do this. Hold on, because you may have already done it differently. So stop what you're doing and watch. When we substitute n for multiplication, I want you to use parentheses, not this. Because what does this look like?
Times.
Or another
It
variable.
looks like an x. Okay?
What
So
about
in
Star.
So I don't want you to do stars. I don't want you to do this because in algebra we use this for x, okay? I want you to use parentheses. So when you are substituting in and you need to multiply, I want you to use parentheses. So you're going to do 2 times the p-value, which is 9, divided by the m value.
But it's 2 or
Okay.
3.
3.
M value is 3, right? So I'm going to do divided by 3. Now remember, you have a calculator, and this calculator can do all of that for you in one step, unless you can already do it in your head. So if you want to use your calculator to do this for you, you're going to do 2 times 9 divided by 3. Just like that, your calculator knows order of operations, so you don't have to worry about that end of it.
18.
And you should get 6 as your answer. So my final answer on this one is 6.
Why don't you use a dot multiplication instead of parentheses?
Once again, that's something that I find people mix that up with a decimal point. So, and plus when you get to Algebra 2, it's really helpful to know that substituting into parentheses is necessary. And even some of the things we do later this year, it will be necessary that you substitute in parentheses instead of times.
Are we able to use these like all throughout high school?
Yeah,
Like
in
every
college.
year?
You didn't text us.
Star, yeah.
But why did they make us do it in our heads?
Because you need to learn what the operation is first. Like you need to know what multiplication is before you just start typing it in. So now that you know what it is, we can move past
And
that.
plus, when
save
you
a
were
little
little,
time.
do you think you'd know how to use a calculator?
Oh no, my 4-year-old, he comes in here and plays on my smartboard. He can do it pretty good. All right, now this looks a little bit different, but it's basically the same thing. It says complete each table, evaluate the expression for each value of x. Now I've heard that you guys did look at tables last year. Yeah. Some?
We get mine. I
You don't
wasn't
like
good
it?
at it.
Okay. It's okay. We're going to get better because we use tables a lot in here. So it'll be fine. What does this mean? Who can raise their hand and tell me what it means for this right here? Jerry, what does that
It
mean?
is the first, like, I forget what it's called, but it's like, you'll be, like, it says it's the first. You do x minus 4, so it'd be 1 minus 4, so you
Yeah.
just replace.
So you replace x with whatever number is here.
Yes.
Yeah. Good. And somebody last period even told me, I thought this was good, that this column is the input, so that's the number you put in.
Yeah, that's how.
And then this column is the output, so that's the number you get out. So that's another good way to think of it. I also have that up here. See?
Mm.
X is input,
That's probably where they
Y
got
is
it
output.
from.
Yep. Alright, so let's try that. If I input a 1 for this x, I would do 1 minus 4,
Or is that a negative 4?
negative 3.
Oh.
Yeah, if it's in the middle, it's a minus. If you start, like if it was negative 2, then if the negative's at the front, then we say negative.
Oh,
If it's in the
okay.
middle, it's a minus.
Okay.
Alright, and then here we do a 2, right? So we're going to do 2 minus 4, which is
Negative 2.
negative 2. Good. And then we do 3 minus 4, which is
Negative 1.
negative 1. And then 4 minus 4, which is
0.
0. So it's kind of a pattern. What happens each time?
It's bigger.
It's
Smaller.
bigger. It's big, 'cause it's getting
Bigger. Oh,
closer to 0.
bigger.
Remember, numbers in the negatives are backwards?
Mhm.
So it's actually getting bigger by 1 each time. Good. All right. Yes, sir.
Can you put like plus and minus 0 so you don't get confused with this O?
I don't think it's necessary, but if you want to, you could, I suppose.
Okay.
All right, so that's it. That's the notes for today. Now, what I'm going to do next is come around and give everybody a textbook, and then we will also learn how to do the homework set up in our spiral. Okay? Yeah, go ahead and stop that.
It doesn't
yeah,
sound like-
yeah, I got it. Okay, are you ready?
Yeah.
Yes. Okay, so in your spiral, here is what you should do. Okay, spiral is where you will do your homework every day. All right, so I want each day of homework on a different page, so always start a new page. So on today's homework, put homework 1-1, so HW1-1.
You just write homework out, right?
You don't have to write the whole word, you can just write HW. And then also, I need for you to write this part. Now, normally I will not make you write this whole part right here. I am going to get a calendar to you, but until I get the calendar to you, I need you to write this down. So also write down page 9, number 12, 14, 28, 30, 40, and 52.
Thank you for making us do all of them.
Okay, good call.
Thank you for not making us do all of those.
You're welcome.
Thank you so much.
Okay, also, I had some questions about what to write down for homework. Okay, so like on number 12, you would write down A minus C. And then you would also write down like what you're substituting in. So you would write the numbers underneath and then write your final answer.
Go beside it.
Got it?
Wait, so we don't have to write like the